Hello, in this video we'll be going through some GCSE worked examples on motion and force. For this one we just need to know a few details about speed, velocity and acceleration. So briefly, in everyday life we think of speed as how fast something is travelling. However, this is too vague for scientific purposes. Average speed is defined as the distance travelled in unit time. It can be calculated using the formula average speed equals distance travelled divided by time taken. The basic unit of distance is the metre, symbol lowercase m, and the basic unit of time is the second, lowercase s, so average speed has units measured in metres per second, or m s to the minus 1, also pronounced as metres per second. As preparation for Form 6 or lower 6th students, it's good to get used to writing the unit as s to the minus 1. The distance moved in a stated direction is known as the displacement. So distance is a scalar and displacement is a vector. Velocity is the distance travelled in a unit time in a stated direction. Hence velocity is a vector and speed is a scalar quantity. Both have the same units, meters per second. Velocity can be calculated using the following formula. Velocity is displacement divided by time taken. So remember, equation or formula, working or substitution, answer and unit, all as important as each other. Question 1. Calculate the average speed of a car that travels 600 meters in 60 seconds. V equals d over t, so speed equals distance over time, 600 divided by 60, 10 meters per second. 2. Calculate the average speed of a cyclist who travels 100 meters in 5 seconds. V equals d over t, 100 over 5, 20 meters per second. Calculate the average speed of a train that travels 4,000 meters in 80 seconds. V equals d over t, 4,000 divided by 80, 50 meters per second. It's extremely important to show you working even for very simple, straightforward questions such as these, so that you get maximum marks awarded in the question. Calculate the average speed of a bus that travels 2.5 kilometers in 500 seconds. V equals d over t. Here we're expressing the 2.5 kilometers in meters. 2,500 meters divided by 500 seconds gives 5 meters per second. Calculate the average speed of a rocket that travels 3,000 meters in 2 seconds. V equals d over t. 3,000 divided by 2, 1,500 meters per second. There should be a little minus 1 there. How far in meters will a car travel in 20 seconds at an average speed of 20 meters per second? Distance equals speed times time equals 20 times 20 is 400 meters. How far in meters will a bus travel in 100 seconds at an average speed of 15 meters per second? Distance equals speed times time. 15 times 100 is 1,500 meters. How far in meters will a person travel in 300 seconds at an average speed of 2 meters per second? Distance equals 2 times 300, 600 meters. How far in meters will a train travel in 500 seconds at an average speed of 25 meters per second? Distance equals speed times time, so it's 25 times 500, 12,500 meters. How far in meters will a space rocket travel in 3 seconds at an average speed of 10,000 meters per second? Distance is speed times time, 10,000 times 3, 30,000 meters, or 30 kilometers. How long in seconds should a car take to travel 500 meters at an average speed of 25 meters per second? Times distance divided by speed, 500 divided by 25, 20 seconds. How long in seconds should a person take to travel 2,000 meters at an average speed of 2 meters per second? Time 2,000 divided by 2 equals 1,000 seconds. How about a bus traveling 5,000 meters at an average speed of 10 meters per second? Time, distance over speed, 5,000 divided by 10, 500 seconds. A train, how long does it take to travel 20,000 meters at an average speed of 40 meters per second? 20,000 divided by 40 is 500 seconds. How long should a rocket take to travel 1 million meters at an average speed of 20,000 meters per second? 1 million divided by 20,000, 5 seconds. When the velocity of a body changes, it's said to accelerate. Acceleration is the change of velocity in unit time. Units of accelerations are meters per second squared. Okay, both of these are correct and pronounced as meters per second squared, but get used to writing it like this. Calculate the acceleration of a car that moves from rest to 10 meters per second in 5 seconds. So it's the change in velocity, so it's the final velocity minus the initial velocity divided by the time. Final velocity is 10, initial velocity is 0, initial is or start velocity, and the time is 5, gives us 2 meters per second squared. Calculate the acceleration of a train that moves from rest to 20 meters per second in 80 seconds. A is final speed minus initial speed over time, 20 minus 0 over 80, 0.25 meters per second squared. Calculate the acceleration of a bus that moves from rest to 12 meters per second in 6 seconds. 12 minus 0 divided by 6 is 2. Acceleration of a cyclist that moves from rest to 8 meters per second squared in 2 seconds. 8 minus 2 divided by 2, 4 meters per second squared. 5. Calculate the acceleration of a rocket that moves from rest to 1000 meters per second, 20 seconds. 1000 minus 0, 20 equals 50 meters per second squared. So all those examples there are from rest to a certain value, but you can also do it not necessarily from rest. And this is what questions 6 to 13 are talking about. So 6 was going from 10 to 22 meters per second in 4 seconds. So 22 is your final velocity, 10 is your initial velocity, divided by the time gives 3 meters per second squared. 20 minus 5 divided by 50, so 5 to 20, 20 minus 5 in 50 seconds, 0.3 meters per second squared. 3 to 12 in 6 seconds, 12 minus 3 divided by 6 gives 1.5. 10 to 0, so this is a deceleration in 2 seconds. Now, final velocity is 0, so we put that first, so it's 0 minus 10 divided by 2 gives minus 5 meters per second squared. The minus just showing that it's a deceleration, it's a negative acceleration. 200 to 3000 in 7 seconds, 3000 minus 200 over 7 gives 40 meters per second squared, or whatever that is on the calculator. I think it's cut off just here on the screen. Change in 5 seconds, accelerating at 4 meters per second squared. So the change in velocity now is the acceleration multiplied by the time. So what is that change in velocity? It's the acceleration, which is 4 times 5, which is 20 meters per second. By how much does the velocity of a train change in 20 seconds when accelerating at 2 meters per second squared? So change of velocity is a times t, so 2 times 20 is 40 meters per second. How much does the velocity change in 3 seconds when accelerating at 3? Change of velocity is 3 times 3, 9 meters per second.